We don't have a solution to this problem yet. And when I go to universities, I try to remind PhD students there that there may be a dissertation hiding in the solution to that problem. Thank you, Mr. Ordway. Good question. Michael.
Mike Nelson at Georgetown University. This is a question both for Vint and for Prodman. You finished your talk by saying that you're proud to be an engineer, and I'm proud to be a physicist. And the reason I'm proud of science and engineering is because when we look at scarcity, we see that as a problem and we try to create abundance. Unfortunately, a lot of our MBA programs teach people to create scarcity because there's more profit in monopoly. A lot of people on Capitol Hill look at scarcity and think that's a source of power. Allocating scarcity is a source of power. How can we get more MBAs, executives, and government officials to think like engineers and physicists and think about creating abundance?
So it's a wonderful question, and it's a wonderful challenge, Michael. One observation I would make is that we do have some examples where abundance turns out to be, I won't say inescapable, but very common. I don't know how many of you were using computers back in the late 1970s. I used to have an Apple II Plus around 1980 or so, or 79, and I remember buying a 10 megabyte disk drive in 1979. The little floppy diskettes only had 100,000 bytes on them, so this shoebox-sized 10 megabyte disk drive was like, Garden of Eden, and it only cost me $1,000 at that point. So not too long ago, a friend of mine called and said, I need to get some more disk storage for my movies and videos, and they went off and they bought a terabyte of disks for $100. Well, I went back and I thought, I wonder what it would have cost me to buy a terabyte of disk storage in 1979. And when you do the math, it would be $100 million. I have a lot more respect for this little terabyte disk drive now. I didn't have $100 million back in 1979, and to be honest, I don't have $100 million now either. But if I had had $100 million in 1979, I'm pretty sure Sigrid would not let me spend it on disk drives. But this gives you some sense for some things that have come out of the engineering and physics world that have led to abundance. What I hope, Michael, is that we can repeatedly point out to people the benefits of abundance. It creates this opportunity to do things you couldn't do before at an economic cost that makes it achievable. And I think we just have to keep pounding that lesson into everybody's head, that when you create possibility, when you create potential, when you enable, you create much bigger opportunities for the profit that you were talking about than trying to squeeze the last dollar out of this bit or that bit per second in a communication system. Now, I probably would fail economics, but I'm a real believer, like you are, that abundance produces better results. Thanks, Michael. I have one here and then one back in the microphone. Yes, sir.
Well, my question is to you. You're at a mammoth corporation. You're doing wondrous things. I think that the business models of today are very restrictive. I think that I'd like your observation. It is difficult for innovators today because of the restrictions that business models and business plans and all place upon the innovator that wants to do something in his garage, which we saw earlier today. And I just wonder, is your company doing anything to short-circuit that, or what do you think about it?
Okay, so this is, you know about the innovator's dilemma. This is a very interesting book that talks about large corporations that have great difficulty accepting the idea that somebody with a brand new idea that isn't yet ready to do billion-dollar business gets ignored because it's not big enough. And the problem is that lots of things start small, like little acorns, and if you don't give them time to grow, then they never mature. Google has, in fact, we just announced today our quarterly results, and we also announced that we are splitting the stock. We're going to issue a share of non-voting stock for every share that you own. Now, why? And this leaves the control, voting control of the company in the hands of the two founders and the chairman for all practical purposes. Now, that's not a common business model, and some people would say, well, that's a terrible idea. The stockholders should be in charge. The reason that has worked for Google is that these guys can take the long-term view because they still have control over the company. And that long-term view says, we will invest even if it drives profit out for a while. We can afford to do that because these guys are willing to take risk. The other thing that's really unusual about Google is that Larry Page is one of those guys who says, you come up and you say, I think I can do X. And his reaction is, why don't you shoot for 10X? Because even if you don't get to 10, you might get to 8, whereas if you shoot for X, you're going to get to 50% of X, and that's less interesting. It's okay to fail. Now, if you fail all the time, that's a different story. But the idea here is that if you try to shoot high enough and you fail, at least you were shooting at the right kind of target. So I've been with Google for 7 years now. The company is about 14 years old, and it still feels like a daycare center and a startup. I don't know if you've ever been into our offices. They're all, primary colors and big bouncing balls and bean bags that I can't get out of after I get into. But the point here is that it's a very unusual company, and I wish there were more like that. We would love to see more Googles happen. That's why we're so committed to this notion of permissionless innovation and openness and accessibility. I hope that you will push that yourself when you have the opportunity. Okay, next question. And Mr. Chairman,
one more. You've been very patient.
Thank you. Anna Brady Estevez. I'm also an engineer, and what I really enjoyed you saying is, like you, when you talk about things that come in the future being like magic, one of the things that's been most interesting to me about being an engineer is not what I already understand, but the things that we don't yet understand. And so, this seems like a perfect occasion at the Arthur C. Clarke Awards to ask you, what are these things that are so difficult for, a visionary who has executed like yourself? What do you think those magic-like technologies will be?
Okay, so of course, I've never been very good about predicting anything. So if you remember what Alan said, best way to predict is to invent. Here are some interesting problems that absolutely fascinate me. One of them is, how the heck does this wetware work? We're learning more and more about how our brains work, and it's more and more interesting. In fact, theorem number 206 reads, everything is more complicated, and that's basically what we're learning about the brain. We're also learning that about genetics. We discovered that just knowing the human genome is not enough. You have to understand what the proteins are that are produced by the interpretation of the genetic sequence. Then you have to discover that the stuff that isn't interpreted as proteins is actually causing certain genes to be expressed or not expressed. So they aren't just junk. They're actually functional things. And then it gets worse. Do you have any idea how much DNA that you carry in your bodies? In your gut, you have more DNA from bacteria than your body has, than your cells have. So you're 90% bacteria and 10% people. And the two have to work together. I mean, we have co-evolved. We can't survive without those bacteria in our guts. So suddenly understanding the human being is actually understanding an ensemble of DNA and the complexity of proteome and everything else. If you haven't read Jeff Hawkins' book on intelligence, please get it. It was written in 2004. I have no idea if there are any more copies, and I didn't look on Google Books, but if you can find it, read it. You want to get me to stop? Okay, I will. But can I say one more thing? All right. So here's what Jeff figured out, and it's relevant to your point about invention and creativity. He's figured out that the way our brains work is that our brains predict what's going to happen next. And so if we're in a familiar environment and our brains correctly predict what happens next, we don't pay any attention to it. It's when something happens that we didn't expect that our brains suddenly focus on that. So the one thing that causes the most interesting inventions to happen is the guy or the gal who says, huh, that's funny, and goes to figure out why. Mr. Chairman, thank you.